Volume is the amount of space occupied by a three-dimensional object. All right. Now, in any three-dimensional object, right, we're going to have something that we call the cross section. Understanding what the cross section of a three-dimensional figure is everything. Because once you could identify what that cross section is, you can find the volume easily, right? So those who were with me a long time, I did this topic already, right? And I always like to refer it to one of those baby toys. I don't know if you all know the baby toys, right? We give babies a toy where they have like a grid like this. And on the grid, they'll have a triangle. They would have like a square, right? They would have like what? Like a, I get to draw that properly. Hold on. They would have probably like a parallelogram. Boom, bang, bang, bang. All right, ignore that. That ain't come out good. Hold on. Right, they have all different shapes. They'll have like a parallelogram. They would have like a kite. Right? Sometimes they'll give them like a hexagon. Right? All these shapes, okay? I don't like how the sun come out. Hold on. They give them what? They could give them like a trapezium. Right? So babies get this toy. Right? And then you know what they give them? They give them blocks now. Right? And you know what the babies do? They take these blocks and they push it through the hole. All these are holes here, right? I'm going to shade them in red. All these figures are holes on the toy. Right? Okay? So the babies know how to identify a cross section of a solid. So if you look at this question underneath right here. Okay? From the time you look at this, right? A baby knows that the cross section of this solid is actually a triangle, and they need to take this. So the triangle for that solid underneath there will actually look like this, right? I'll put it. So it's like a right angled triangle, right? So the baby knows, right, to take this, the Naya Henman, the baby knows to take this block that they get for Christmas, they now get for Christmas, and they know to push it through this one, right? So this block going through this one. So they push it through and they laugh, geek, 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 geek. That is how they identify the cross section of a solid. Remember the baby toy, right? So let's write a note to that effect, right? So identifying the cross section of a solid is everything, right? So the cross section right, that's all. The cross section of a solid is the two-dimensional shape obtained when a solid is cut by a plane. All right. So what this means, okay? Your cross section, I am giving you all the definition as what the baby is going to identify when they are pushing this this block through this 2D shape here, right? That you are seeing on the baby toy here. But the official CXC definition is that the solid, the cross section of a solid is the two-dimensional shape obtained when the solid is cut by a plane, right? Meaning that if I have this solid underneath here and say I cut it in half, right? Say take a knife, right? And you cut this shape in two. You cut it down the center here, boom, right? It means the shape that you will see in two pieces when you break it, so it would be two triangles. That's another way to identify the cross section of a solid. But we're going to take a baby toy, right? So we go in now. So this question here actually wants us to find the surface area and the volume of the triangular prism below. So surface area is very simple, right? Surface area is the total area of all the faces. Since primary school, everybody should know what the face of a solid is, right? Of a solid. All right? Everybody good there? So in order to find the area of this solid in question 1, you need to find the area of every face, add them together, right? Then we have the volume. Volume of any solid is the area of the cross section, right? That's why I told you it's very important to identify what the cross section is. Multiplied by the distance from one cross section, or let us put multiply by the distance between the two cross sections, right? Because every solid, every uniform solid will have two cross sections, right? So multiply by the distance between the two cross sections. All right? Everybody good there? So now prior to today, because I'm doing a lot of research now to try to get these things out to you all much better, right? Prior to the date, when teachers teach in volume, right, they usually say the area of the cross section multiplied by the length or the height. The length or the height. I don't know, Rishana, you did this with me before. I'm sure I used to say length or height. So I'm moving away from that and calling it the distance between the two cross sections. That's what we multiply by, because sometimes you always see the height of the triangle and you'll get messed up and it will put the height of the triangle. Or you'll see the length of something else and it will put the length of that, right? We'll work in with the area of the cross section multiplied by the distance between the two cross sections, right? That will make life real easy for you. So we need to engage two formulas here. I want somebody to identify the different shapes we have for our cross sections here. What are the different shapes? Anybody? We have two shapes here. What are the two shapes we have? So we have how many triangles? Anybody? Come on, y'all get involved. How many triangles we have? Two. Who is not seeing two triangles here? Raise your hand, please. Brendan, you seen two triangles here, brother? Right. We have one in the front, one in the back, right? Melissa and Melika, all seen two triangles here? Francis, what's going on with your camera? Danae, where camera? Well, I know Zaria camera not working. Marissa messaged me this morning. Who is in under you, Von David? Who is in under you, Von David? Hello. I don't even know who's that. You, Von David. Hello, hello. I'm removing this person from the class now. Because I don't know who this is. Oh, Nico Sewell. All right. Oh, God. Message now. Jonathan, what's going on with your camera? Leo King. I don't have a Leo King. What's your name? I no problem, Micah. Leo King. Leo. That's not your name. I know that's not your name, but that's the name I seen on the camera. Leo Leave, yes? I ain't sure what's going on there. All right, let's go. So we have two triangles, and how many rectangles do we have? Come on, y'all speak it out. How many rectangles do we have here?
Two.
Two?
Oh, wait.
One?
Three.
Three. Thank you, Alejandro. We have three triangles. I see Jonathan was holding it up too. We have one on the top. Aiden, watch it. We have one on top, one in the back, one underneath. All right, that's fine, guys. This parent keep. She wanna get the child in the class, but the child's sleeping. Where Leo King gone by? Leo King, what's your name, son? Say that again. Dion. Dion what? Leon. Right. Yes, I have a Leon. Yeah. I'm gonna send this link. This has always happened like first day when we come off our vacation period. Right. I think the child now coming in here. No, this is Thomas. Right, let me just add this child in the, anyway, I could add them in the group after. They will come in a song. We were all listening tape and I didn't even stop the tape. Let you go. All right, so let's write down the two core formulas we'll be using here to start off, right? We need the formula for area of a triangle. Anybody, what's the formula for the area of a triangle? Anybody, come on, quickly, all you know this. Base of the triangle multiplied by the height of the triangle all over 2, which is the same as a half of base multiplied by height. Everybody good there? Morning, morning. I know you now came in there. What we doing right now? And today's your first class. Is it Tyrese? Tyrese, morning. Tyrese. Right. So yeah, right morning. I know you now wake up to you could put on your camera. If you could put on your camera, put on your camera, please. Right? Right. Right. So here we're going on. I just give these notes up here. This is all we did for the morning, right? Okay. Today's first class, we were just settling. I was getting a lot of messages from parents for the children to join, right? This is what we do. We're looking at solids. We're going to look at volume, right? So this is the first question we're doing here. We're going to find the surface area of this triangular prism, and we're going to find the volume, right? So, as I was saying, class, we have two triangles. The area of a triangle is the base of the triangle. What is the base of the triangle here? Anybody? You can mute your mic, Tyrese. Anybody, what is the base of this triangle on the side here? Come on. What is the base of the triangle? 12. Excellent. What is the height of the triangle? 16, right? So I could work out that right here one anyway. We work it out right here. So the base of the triangle is 12 multiplied by the height of the triangle, which is 16 all over 2. So 12 multiplied by 16 divided by 2 is what, Jonathan? 12 multiplied by 16 divided by 2 is what? Jonathan? 96. Somebody second 96. 96. So that'll be 96 centimeters squared. That is the area of one triangle. Base multiplied by height divided by 2. Right? Now, we have three different rectangles. As Alejandro said, Jonathan said it also. What is the formula for area of a triangle? Come on, I need somebody to tell me. What is the formula for area of a triangle? No, brother. That is that's I'm sorry, not triangle. I say triangle. Rectangle, right? You're correct. That is the area of a triangle. What is the area of a rectangle? Is rectangle we're looking at now. Yeah, simple, right? Rectangle. Woo. Area of a rectangle is equal to length multiplied by breadth. Right? What we have three different rectangles here, right? Three. Let's work. We're going to deal with rectangle one. So let's put in area of rectangle one. Somebody give me the length and breadth of rectangle one. Any rectangle could be rectangle one. Let's give me the length and breadth of one rectangle there. Anybody? Come on, open up. Adams, give me one of the rectangles there. Length and breadth. Go ahead, Marissa. I see your mic off. And after I identify it, I'll show you all it. I'll draw red lines around it. 20 and 10. Excellent. So let me show you all the rectangle that she is looking at, right? So she is looking at this rectangle above here. So watch it. Boom. That's this. All right. This line here. This line here. You all see that? Nico, see you see that? I see you see a lag in Nico see. So she's looking at this rectangle above here. All right. Boom, bang, bang, bang. Now, guys, this is probably the easiest these questions going to get to. After this is peace. All right. So everybody seen rectangle one? We're going to do 20 multiplied by 10, which will give us 200 centimeters squared, right? Who is still not seeing that rectangle there? Raise your hand if you are not seeing that rectangle. Everybody seen the rectangle. All right, good. let's look at the rectangle in the back now. Oh, no, wait. Let me get somebody to tell me. Give me another rectangle here, guys. I want to give you all a little hint here. You see, all 16 by 20. All right. 16 by 20. 12. 16 by 12, no. So let me show you all something. The distance from this cross section to this cross section here. You see the distance between all these vertices of the cross sections that I'm highlighting here with blue? The distance between each one of these vertices will be how much? What the distance on top here be? Let me see you following. Anybody? 10. Excellent. So here would be 10 centimeters. Down here would be 10 centimeters. And well, in front here is 10 centimeters. So Brendan, you want to re-answer that? Give me another rectangle. We're dealing with rectangle 2. So area of rectangle 2. Give me the area of another rectangle. Anybody? Come on, guys.
By 10.
So what by 10? You're going correct.
6 by 10?
I hit 30.
No, sir. I said 10 by 10. I did say 16.
16 correct.
Oh.
16 correct. 16 by 10. So let me highlight that rectangle, right? Because I feel we're not seeing it. 16 by 10 will be this rectangle behind here. Everybody see the rectangle?
Yes, sir.
Right? Now it's shaped kind of off here, but that's the whole thing about 3D, right? They don't draw it exactly, but that is a rectangle behind there. Okay? Everybody see the rectangle? The length of that rectangle will be 16. Right? 16. And the breadth of that rectangle will be 10. 16 by 10 is 160 centimeters squared. Everybody good there? We have one more rectangle here. Leon, what's the length and width of the last rectangle here, Leon? The last rectangle. So we deal with the rectangle on top. We deal with the rectangle behind. What's the last rectangle we dealing with here, Leon?
12 by 10.
Boom. Proper thing. 12 multiplied by 10. Right? So that'll be the area of the last rectangle. Area of rectangle 3 would be 12 multiplied by 10. Right? Which is 120 centimeters squared. Okay? So we have the area of the 3 rectangles. We have the area of 1 triangle. You'll actually have to multiply that by 2 because it's 2 triangles. So the area of not cross section, of surface, area of surface would be equal to, we can add all these things above here, 200 plus 160 plus 120 plus 96 multiplied by 2. Everybody clear on why I'm multiplying 96 by 2? Foster, why did I multiply 96 by 2? Talk to me. Why did I multiply 96 by 2, Foster? Come on, Lucky, we ain't come here to play. It's serious business. Why did I multiply 96 by 2, Foster? You could just unmute your mic and say you don't know.
I don't know.
Shania, why did I multiply 96 by 2 down here? Why did I multiply 96 by 2? Shania. You can just say you don't know if you're not sure. All right. Let me go. Alyssa, why am I multiplying 96 by 2? Jonathan, I know you know. Right? Alyssa don't know. Tyrese, why did I multiply 96 by 2? To take away from the triangle. You kind of had the right thing, which is triangle. Go ahead, Shania, saying something.
Because it's going to count for 1 triangle.
right? That area of the triangle, there's just the area of one triangle, brothers and sisters. I need the area of the two triangles. It have a triangle in the front, right? Foster, I find I ain't seen you good enough. I find I ain't seen PCFA. Same thing with Alyssa. That's why there's no following. Right? Alyssa, you seen it have two triangles here?
Yes, sir.
Right. So you need the area of the two triangles. That's why I put 96 multiplied by 2. Okay? So somebody hit me the answer and now the final answer.
617.
617. 617, Chucham?
No. 7.
And this would be centimeters squared. That is the area of the surface, or the surface area, right? So the next thing they ask us to find is the volume of the triangular prism. I told you all the volume of any prism that you're finding would be the area of the cross section multiplied by the distance between the two cross sections, right? Okay? So, Foster, remind me what shape is the cross section of this prism here? Foster, what the baby taking this block here, this block that I have in front of you? A baby taking that block and pushing it into which one of these shapes here? Foster? Right. So the triangle is my cross section. Right, Alyssa? You seen that?
Yes, sir.
Right. In other words, you visualize a knife. Right, Zanaya? Visualize a knife. You're coming with a knife. You're cutting that shape in two. And when you cut that shape in two and you open it, so you're supposed to see the same shape on both sides. Right? That's what you're supposed to see. So our cross section is the triangle. And we don't have the area of the triangle, my children. What was the area of the triangle? Somebody tell me. Come on. Area of the triangle. 96 multiplied by what is the distance from one triangle to the next, Rishana? What's the distance from one triangle to the next? I said from one cross section to the next, right? The distance between the two, 10 centimeters. Excellent. Who's not able to see that? The distance from one cross section to the next, which is the distance of one triangle to the next, is 10 centimeters. So I simply multiply this by 10. And that's how easy your volume is. 960. Centimeters what? Its volume should be centimeters what? Cube. Right, proper thing. Anybody need to write it? So I need guidance. I don't know what to do here. I need some guidance, right? So what's the first thing I should do here, boy? Anybody, what's the first thing I should do? Let's go. So I go down and write the formula for the area of a triangle first because I have no idea how to find this area, right? I need it to stick in my head. Area of a triangle. What is the formula for the area of a triangle, my children? That's what I like to hear. Base multiplied by height all over deuce. Right, so I write that in red because I want to remember that, so I write my formulas over and over, right? So let go. What's the base here? 8 by 3 divided by 2, which will give me 12, right? 12 is my area of one of the triangles, right? So, what's the next thing I do now? I don't know what to do now, Leo. Help me. No, well, we are out to the triangle 1 and 2. Remember, the triangles on the both sides are equal. Just like up here. The triangles on both sides were the same. Right? 12 centimeters by 2, right? That's when we can do that when we do the final thing, right? What we need to do next?
Get the area of the rectangle.
Right, let me go. How much rectangles we have? Area 3. So let me go. Area of rectangle. This question have two rectangles that are the same. You all saw that? The rectangle on this side and the rectangle on the next side are the same. Both of them will be 5 by 6. You agree, Brendan?
Yeah.
So we have two rectangles that are actually 5 by 6, right? So I could put rectangle 1 and 2 will be equal to 5 length multiplied by breadth, which is 30. Right? So when you're working out this, you just multiply 30 by 2, right? So rectangle 3, which is the rectangle where?
To the bottom.
To the bottom. Excellent. Excellent. All locked in by area of rectangle 3. So that'll be equal to, what was the dimensions at the bottom? 6 by
8.
8. Proper. 6 by 8. 6 eighths are?
48.
Right. So here's where you have to be very locked into what you're going to write now for the total surface area, right? Okay. So let me go. We're going to find the total surface. Where that T come from? Eh? Surface area. So let me go. I started with the two triangles, right? So what's the area of one triangle again? 12? 12 multiplied by, how much triangles we have? 2. I put 9 brackets. Plus, how much in the 30 centimeters rectangle we have?
2.
And then what's the last rectangle?
6 by 8.
Which is 48. So when we add up all these, what would be the total surface area? Somebody second that. Because I'm not calculating these things. 132 centimeters squared. That's my total surface area. Now we move to volume. Dog food volume is. Right? So volume of any prism. Right? Write this out for me. Area of cross section multiply by what? Who can tell me? Multiply by what? Distance between. Distance between the, I put in the word 2. Right? Distance between the two cross sections. What was the area of what one cross section? Let me hear a little. What was the area of the cross section of that prism number? First of all, the cross section was a what? What the cross section was? What was the cross section of this solid here, my children? A rectangle. I hear some chatter there, but I think I get my answer yet, you know.
A triangle.
Thank you. A triangle, right? Eden Chutram, you have to see it like this. When you come with a, if you come with a knife, right, and you cut this in half, right? You cut it down the center. You're supposed to be seeing two triangles on either side when you break it, right? Okay? So the cross section here will be the triangle. So what's the area of the triangle, my children? You all have it in front of you. What's the area of the triangle? 12 multiplied by what was the distance from Well, between the two cross sections.
6.
6. I think it was 6 too. Let me scroll up and make sure. Yeah, 6. The distance from here to here is 6. Let's follow two vertices, right? Look at the distance from this vertice to the corresponding vertice in the next triangle, right? That distance is 6. 12 by 6 will give me 72 centimeters. What? Centimeters what? Cube. Because it is volume. The diagram below, not drawn to scale, shows a triangular prism with right angle isosceles triangles at both ends, right? You have right angle isosceles triangles on both ends. What does isosceles triangle mean? It means that this side is the same length as this side. Right? Excellent. That's the same thing going on in the back here. This side will be the same as this side underneath here. Here will be 5 cm. Down here will be 5 cm also. Right? Right. So they said angle ABC is 90 and AB is equal to BC, which is equal to 4. AB is equal to BC, which is equal to 4 centimeters, right? Calculate the area of the triangle ABC, right? Dog food. Who could help me now? I don't know what to do here.
There will be area of triangle base by height over 2.
All right, that's not. I put 5 in the back here. It's 4. 4 cm. Right, there you go. So give me the formula. Area
Triangle A, B, and C was the base by height over 2.
I hear saying, all right, base by height over 2. Excellent. Triangle ABC. This is just the dimensions of the triangle, right? When I say triangle ABC, it just means A to B to C, right? That's the triangle. And this will be equal to base multiplied by height all over 2. All right? So what was the base here? I didn't hear anybody say what the base was.
The base will be
4 multiplied by 4 all over
2.
with 8.
Yeah, 8 centimeters.
Right, that's the area of the triangle, right? Then they came and said the volume of the prism, so they gave us the volume. They said the volume of the prism is 72 centimeters cube. Calculate the length of CD. CD being the distance from one cross section or one triangle to the next, right? So somebody tell me what is the formula for volume, because I need to engage that formula, right? What is the formula for volume of any prism? Go ahead.
So the area of cross section.
All right. Area of cross. Could we just start call cross sections? Yes. Area of cross section multiplied by distance between two cross sections, right? I make BBS there, cross sections, right? Okay, everybody good there? What is the area of the cross section? We actually have two things here. We have the volume of the prism, right? Well, the volume of any prism, this is just the formula, right? Hey, I freed all the next thing, all revising, and all see C minus S, and I want to know what else. That's how much I freed all. I put in cross section, yes? Cross section. Next thing, somebody revising, and they seen C minus S, and they want to know where to get that from, by? I know all you know, it's 20 years of teaching now, you know. All right, on the word cross section now, please. You hear me, Shana? Write out that word. I want all to be revising and saying where does man get C minus S from, by? C, well, cross section with a dash in between, right? Right. So what was the volume? What's the volume? They gave us the volume. What's the volume of this prism? 72. So I put in 72 is equal to what is the area of the cross section? We have that. What's the area of the cross section? 8 multiplied by, I will just call it the distance between the two cross sections, what they calling it, right? They calling it the edge CD. So let's put CD, right? So I need to find CD. I have an algebraic equation here. So I need to move CD. Well, not CD, sorry, I'm moving 8. Move 8 to the side. And what do I do with it? I do the opposite of multiply, which is 2. Let's go. Let's go. So 72 divided by 8 will tell me what CD is. What would CD be? So I could go up here now and write here to be 9 centimeters. All right? Cool. Now next question. Calculate a 1 decimal place the length of the edge AC. The children who came to the December classes should be very efficient in finding the length of AC. What kind of triangle this is, my children? What do we do to find the longest side in a right angle triangle called my what? What is AC called? Hypotenuse. Excellent. So I want to find the length of my hypotenuse, right? Let me draw the triangle down here. I separated the triangle. This is the triangle. Boom, bang, bang. Right? It really look isosceles. That's all. I'm gonna fix that. All right, we go in boom, bang. Wait, what's all that way? Let's look more isosceles. Right. Right angle, 4 cm, 4 cm. They wanted to find A to C. Right? A to C is my what? Somebody was saying it. A to C is my hypotenuse. Right? That is my hypotenuse. What is the formula? We call the hypotenuse common A, right? The other two sides of that should be referred to as common B and common C. So give me my formula to find my hypotenuse. Pythagoras' theorem, belt it out. Well, let's see what one little Christmas vacation is do. I go to write Christmas. Could somebody tell me what Pythagoras' theorem is, please? Isabel. Go ahead. Somebody else saying it. Go ahead, Sana. Thank you, sister. A squared is equal to B squared plus C squared, meaning the hypotenuse squared is equal to the sum of the other two sides squared, right? Now, in this case, the hypotenuse is what we're looking for. So I'm just going to replace common A with AC. That's what they're asking for. So AC squared is equal to common B. What are we calling common B? Common B is what? 4 squared plus common C.
4 squared.
So AC squared is equal to 4 fours are 16 plus 4 fours are 16. 16 plus 16 is what?
32.
Now I need to find AC, not AC squared. How do I get rid of this squared here, my children?
Square.
You do the opposite of squared on the right hand side. So AC would be equal to the square root of 32. Right, Tyrese? You understand this, Tyrese? All right. So, Tyrese, you have a calculator. I have a calculator. Find the square root of 32 for me. And it said to give the answer to 1 decimal place, children. Tyrese, find the square root of 32 for me. You don't engage the calculator. Press the square root sign and then press 32 and press equal. Hit me.
Yes.
5.7 centimeters. right? Like we have all these bad boys now. We have all these lengths, right? Let me see what they're asking for next. Right, they wanted to calculate the total surface area. I put it in part. I want the total surface area, and no, they give us the volume already. So that's what the total surface area. Then they want to state the number of faces, edges, and vertices in this prism, right? Okay. So I'm gonna pull up these two things. Copy. I'll put it up here because we just doing these parts now, right? So we don't do the other parts. So let's get these parts done. This was C. This was C and this was D. All right, go. Calculate the total surface area followed by telling me how much faces, how much edges, and how much vertices this prism has. Go. I'll give you another 3 minutes. Here we go. Right. So part C and D, they want us to calculate the total surface area. Right? The diagram below not drawn to scale shows the triangular prism with right angle isosceles triangles on both ends, etc., etc., right? Let's see the surfaces. Somebody tell me what's the first thing we're going to do here. I have no idea what to do here. What's the first thing we're going to do? Base by what? Right, but we could just find the area of our triangle first. When we add in, at the end, we could multiply by 2. So area of triangle is what? Give me a formula. I will write in our formula at all times. What's my formula? So what's my base? But now we had this already. You don't need to rework this. Yeah, we worked this already. What's the area of the triangle? Let's give me the final answer.
16.
16, Jenny?
Yes,
Right. Or it's not 16 or 8.
see, once in a bit,
All right, let me just put 1 for now. Area, right? Area of triangle is 8 centimeters squared, right? Right, let me do the rectangles now. So area of, it have 2 of the same rectangle, same rectangles here. So we'll call it 1 and 2. Area of rectangle 1 and 2. Area of rectangle 1 and 2. Which are the 2 rectangles that are the same? My writing pad messing up here, boy. Right. Which 2 rectangles are the same? Come on, which 2? Right. So basically, it's the one underneath and the one in the back. Everybody agrees? The one underneath and the one at the back, right? So we go in. It's just we'll multiply by 2 when we find out the total surface area. So the area of rectangle 1 and 2 is the same, which would just be length multiplied by breadth, which is 9 fours are 36 centimeters squared, right? So when we add in it at the end, we'll just multiply it by 2, right? So what is the area of the last rectangle? We'll call it rectangle 3. What's the area of the rectangle? Come on. 5.7. Proper thing, sister. That's the rectangle on top now. 5.7 minus 9, which will be what? 51.3 centimeters. All right? That's centimeters squared, eh? Right. So now we're going to calculate the total surface area. Total surface. Right. What we adding? Talk to me. What we adding there? What's that, Tyrese? I ain't sure, but let me start to add. What we adding first, Tyrese? This 8. We just adding 8 alone or 8 multiplied by something?
8 by 4.
Because it's 2 triangles plus 36 by
2.
plus 51.3. Where again when you add it up, Tyrese? Somebody second that.
I get
139.3. 131? Check it over. Let's check it over. Brendan, check it over. Tyrese, check it over. Make sure again, it's 7 meters squared, eh?
5 faces.
5 faces, right? Edges. How much? 9? Yeah, it's 9 because it's 1, 2, 3 going right around. Then each triangle has 1, 2, 3, and then 1, 2, 3, correct? And then vertices.
6.
Yep. Everybody good here?
Yes.
We're running right now. I'm moving this, sir. Because I'll feel like I didn't answer it out. We did it high up. Yeah, let's see if we can get these two done quickly before we leave. It is 10:39, right? So here, man, I've given you all 10 full minutes to try these two, right? That cuboid is dog food, but I've given you all the formula for area. I've given you all the formula for area of a trapezium, right? Right? So that'll be a half of A plus B multiplied by the height, all right? For this trapezium here, a trapezium has 2 parallel lines, right? In front here, this is a trapezium. So A would be 8 and B would be 14. And your height is the distance from one parallel line to the next. Your height is equal to 4, right? So I want you all to think. I've given you all 10 full minutes, right? We come back at, well, I come back. I just walking in the back there to come back. 10 full minutes. At 10:50, we correct both of them one time, and then we'll end the class. All right, let's go. Calculate the volume and the total surface area of the cuboid. Volume of a cuboid is a standard formula, right? Volume of cuboid would be equal to length by breadth by height, right? And they gave you all those things there. So this will simply be equal to 11 multiplied by 5 multiplied by 6. Now if you did area of the cross section multiplied by length, you'll get the same thing, same formula. So what do you all got when you multiply this? What's the volume of the cuboid? Anybody?
330 centimeters. Square? No, cube.
Cube, right? Somebody second this. Liam, that's what you get? Lucas.
Yes, sir.
Right. So we're going now to the total surface area. You know we could actually do this total surface area as one, eh? Total surface area. So watch it. Give me the area of, let me go in any order. Give me the area of one shape there, one surface. Anybody?
11 by 5.
11 by 5. That's the one at the bottom, right? So what should I do? What she height say? 11 multiplied by 5. I multiply that by 2 one time. Cool it then, Chutram. Because that'll be the bottom and the top. Right? Give me our next one there. Plus 6 by 5. Somebody say 6 by 5. I'm multiplying that by 2 one time. Because it's 6 by 5 on this side, 6 by 5 on the next side. Multiplied by 2 one time. And we have 2 more. Which was it? 11 times 6. I'm multiplying that by 2 one time. Right? And you belt out all on your calculator as 1. Right, Foster? Where you get a Foster? When you belt out all this?
Yes.
Right. 302. Come now, man. All when I give all the workers now that's a watch and pray and hope and hope for a miracle like go just appear on your page. That question done, you know. That's the volume and the total surface area there. That question done. Right, let's go here now. Volume. So this now we're gonna work with the volume. It's a trapezoidal prism, right? So the volume of any prism is equal to the area of the cross section multiplied by the distance between the two cross sections. So the cross sections here would actually be trapeziums, right? So we have the area of trapezium, and that will be a half of A, which is, I told you all A is what? A is one of the parallel sides. For those who don't know what trapezium is, a trapezium has two parallel sides, right? Right. So a trapezium has two parallel sides. Well, a pair of parallel sides. And this will be A, this will be B. Right? So what is A for this trapezium above here, guys? 8 multiplied, not multiplied, sorry, plus. What is B?
14.
Multiplied by what's the height? The height will be the distance from one trapezium to the next, the perpendicular distance. Right? So I'll join our 90 degrees here. This is your height, right? And we have 4, right? That's the area of your trapezium. And when you work this out, what are you getting here, my children? Huh? 11.5. Somebody had a second now for me. 11.5 centimeters squared. 44 song and more correct.
I got 44.
44, just 44 flat?
Yes, sir.
Yeah, that song and more correct.
I get 32.
32? Brother, do 1/2, open bracket, 8 plus 14, close bracket, multiply by 4, and you will get 44. Right?
I just ended up adding 8 and 14 and multiplied by 1.
Nah. You could do that, no? You could do that, but you don't know what you're doing. You do 8 plus 4 first, wherever I get multiplied by 4, 8 plus 14. I feel I do 8 plus 4. Right, let go. So therefore, area, no, it's volume you're trying to find first, right? That was going to do. So therefore, volume is going to be equal to the area of the cross section, which is 44, multiplied by what's the distance from one cross section to the next? Dog food. All around here is 10 centimeters. All these sides are 10 centimeters. How one height in the back there is 10 centimeters also. So this volume here will be 440 centimeters cube. Right? That's my volume. Surface area. We could do this as 1 too, eh? Surface area. Watch it, eh? We do it just like how we do the last one. So we know that the area of the trapezium is 44. So that'll be 44 multiplied by how much trapeziums it have here? 44 by what? 2. Because that 2 trapeziums. It have one hiding in the back, right? Plus, how much rectangles we have here? Let me see you following. How many rectangles we have? How much is that, Janae?
4.
4. Excellent. One on top, one behind, one in front, one underneath. So let me go. Somebody should have it written now. Give me the formula, not the formula, sorry. The working for the area of the first rectangle. Whichever one you all have first, doesn't matter. We need to write all 4. Hit me, anybody?
5, 5,
5 times 10. Is this one? 5 by 10.
Yeah.
5 by 10 is the one in front, right? Give my next one. 14 by 10. Let me see which one this is. 14 by 10. 14 by 10 is underneath. That's underneath. All right? Let me go. Give my next one.
7 by 10.
7 by 10. I'm going underneath here. Plus 7 by 10. Which one that is by? That's behind. 7 by 10 is behind. Last one.
8 by 10.
8 by 10 is the one on top. So what's my total surface area here, my children? 420 centimeters squared, right? Somebody second that.
28.
28.
28.
Right. Proper thing. Right? So guys,